Hi everyone, Dwayne Davis here. I'm a doctoral student at the New Jersey City University, and today you're going to learn about a few things. You're going to learn about two descriptive statistics called the correlation of coefficient R and the coefficient of determination R squared. We're going to go over creating scatter charts in Excel, creating a linear line, formatting your scatter chart, and interpreting the information and interpreting your data to then interpret your data. So this is what we're actually going to have as an end product. We have a scatter chart here with a linear line, the equation of my slope of my line. I have my coefficient of determination, R squared. I have a number of linear regression calculation statistics here. I also have a predictive equation for my slope that I will then pull from my data. And I also have on the side the data that I will actually use. So how do we actually get here? So let's go to sheet number 2. So first we want to understand our coefficient, our correlation coefficient R. When we're analyzing two variables or more, the correlation coefficient R explains to us if there are any associations between the two variables. The values for R ranges from -1 to 1. A value of 0 tells us that there is no association or relationship between the two variables. A value closer to 1 tells us that there is a perfect, that actually a value of 1 tells us that there's a perfect positive correlation. So that means that a change in our dependent variable creates a perfect equal change, positive change in our dependent variable. Conversely, a value of R closer to -1 tells us that there is a perfect negative relationship when our value is -1, so that that means a positive change in our, our independent variable creates a negative change in our dependent variable. We calculate the coefficient of determination by squaring our correlation coefficient, and once in the coefficient of determination explains to us how much a change in our independent variable affects the change in our dependent variable, and that ranges from 0 to 1. A 0, R squared, tells us that the changes in our independent variable can attribute to 0% of the change in our dependent variable. A value of R squared closer to 1 says that 100% of the change, if the value of R squared is 1, 100% of the change in our dependent variable can be attributed by the changes in our independent variable. So let's get started with our data set. So today we have body fat in the left column, that is our independent variable, and abdomen size in our right column, that is our dependent variable. Body fat is in percentage, and the abdomen size is in inches. So we first want to create a scatter chart that just gives us a visual of these two datas and how they relate to each other. So we're looking for preliminary information. So we're going to highlight our data set. We're going to click on scatter. We're going to click on marked scatter, and our chart pops up. We're going to make this a little bit bigger. So this chart doesn't really tell me much right now. What I want to do is I want to change the format of my chart. So I'm going to go to Chart Quick Layouts. I'm going to click on this drop down arrow. And what I'm looking for is my FX layout. This is going to give me more descriptive titles on the right, at the bottom, to the left, and to the top. And it's also going to create for me a linear regression line. Okay, so it gives me a linear line. It also gives me the equation for my slope. And I can see here that the data is tightly, in some ways tightly collected and formats itself along the linear line. So there's something there. There's some strong relationship there, but I just don't know how strong at the moment. This chart also gives me the equation of my line, which is y equals mx plus b. M is 1.1759, and my b is my y-intercept, which is 70.447. My r squared, as I mentioned before, is my coefficient of determination, and that is at 0.73531. We'll look at that a little later. So let's format our chart right now so that it's more descriptive. For my horizontal axis, I know that this is my body fat percentage. For my vertical axis, I know that this is my abdomen size in inches. I can get rid of these horizontal lines in the back by clicking on the lines and then clicking delete. And then I can get rid of a lot of this white space that's unnecessary to allow my chart to be better visually. I notice that there are no data points that lie below 60, so I'll start at 60. And I notice that there are no data points on my horizontal axis that lie below 5, so I'll start at 5. Okay, so now I have my scatter, and then I will change the heading of my title to body fat versus abdomen size. Okay, so basically what I'm trying to figure out is what is the relationship between a person's body fat percentage and their abdomen size. Is there some relationship? So it looks here that there is a positive relationship because as the percentage of body fat that a person has increases, the abdomen size relatively increases also. However, I would like to calculate a regression and regression statistics. So how do I do that in Excel? I have my data set here to the left, and I'm going to use a function called line estimate. So I'm going to click into my already populated regression boxes at the bottom, and you can type this in also. And I will right next to slope, I'm going to click equal line estimate. So line estimate will spit out a calculation for my slope, and I will then need to take 2 more steps, actually 3 more steps, to have Excel spit out my other regression calculations. So line estimate is then asking me for my known y's. So I'm going to highlight all of my known y's, which is my dependent variable, abdomen size, comma, so I can separate that. Then it's asking me for my known x's, which is my independent variable, body fat percentage, comma. Then it's asking me for my constant, which I will put a 1 for true, and I'll always put that unless you know otherwise. I'm going to then put a 1 also for true for stats, and I'm going to hit enter. And Excel doesn't populate, it doesn't give me all of my regression calculations, it only gives me my slope, but I can fix that. But what it did confirm is that my slope is actually correct, 1.1759. I have a few empty cells here, so there's 2 columns across and 5 rows down, and I want to fill that in with all of my other important regression calculations, my errors in M, my f-stats, my sums of squares, my y-intercepts, etc. And my coefficient of determination, which will allow me to calculate my correlation coefficient. So what I want to do is I want to click on the cell that has my calculation of slope. I want to click over 2 columns and down 5 rows. I then want to I then want to click on Control with that highlighted, and then click U. So that's Control U. And then I want to click Command Enter. And Excel then populates my 2 columns and 3 rows down with all of my regression calculations. I want to bring your attention to the coefficient of determination, r squared, which we talked about earlier. That tells us that any change in our independent variable can be attributed to x percentage of a change in our dependent variable. So for this example, 0.7353 tells us that 73.53% of the changes in abdomen size can be explained by changes in body fat percentage. I use the coefficient of determination r squared to calculate my correlation coefficient, which tells me the strength of the relationship. So if you remember, the coefficient correlation r ranges from -1 to 1. In this instance, and the closer we get to -1 or 1, the stronger the relationship is, negatively or positively. In this instance, we're at 0.85, which is pretty close to 1, and that tells us that there is a strong positive relationship between the body fat percentage a person has and the abdomen size of that individual. What can we do with this information? We have our y-intercept b, we have our slope also, and we have our slope, we have our coefficient of determination, we have our slope, and we have our y-intercept. What we can do with the formula of our line is we can predict what future abdomen size could be. So y equals mx plus b is the equation of my line, and so I can take that and fill in the information and try to figure out what abdomen size could be if I change x. So my formula is abdomen size equals J29 m times J30 x plus J31 b. Y equals mx plus b. So if I change x to 10, which is my percentage of body fat, I should see it now changes my y, my predicted abdomen size. If I go up, since I know that there is a positive correlation, my abdomen size should go up. If I go up further, my abdomen size should go up again. If I go to 40, my abdomen size is predicted to be 117.48 inches. If I look at my data set here, and this is just an estimate, it's relatively close to what the abdomen size could be. So this is how you calculate the coefficient of determination, r squared, the correlation of coefficient r, how you create a scatter plot, a scatter chart, estimate your linear line, and find the equation of your slope to describe your data in Excel. I hope this helped. Thank you.